Hey everyone, welcome to This Explainer. Okay, I am absolutely pumped for this one because we are diving into what is literally one of the most fascinating mysteries in the entire history of science. Let's just jump right in, shall we? We're looking at the story behind one single world-altering date, November 24th, 1859. That, of course, was the date Charles Darwin published On the Origin of Species. It was a book that completely, fundamentally transformed how we understand the living world, our history, and honestly our place in the whole shebang. But how did he actually get there? What were the breadcrumbs that led up to this massive breakthrough? Well, let's find out together.
Now, to really grasp the massive stakes of what we're talking about today, I love looking at this quote from the brilliant evolutionary biologist Theodosius Dobzhansky. He said, "Nothing in biology makes sense except in the light of evolution." I mean, wow, that is a massive statement, right? But it hits the nail right on the head. Today, evolution is the absolute bedrock of modern biology. Everything we know, genetics, molecular biology, paleontology, it all rests on this one single framework. But the crazy thing is, before 1859, the scientific world looked entirely different. The whole concept of biology was fundamentally fractured.
So, the big question we need to answer is, how was this monumental theory actually built? You know, pop culture loves to paint this picture of Charles Darwin as this lone genius who just sort of woke up one day, maybe while staring thoughtfully at a bird, and boom, the entire theory of evolution was mapped out perfectly in his head. But the reality? Actually, scratch that. It's way more exciting. It's more like a gripping, decades-long detective story. Darwin didn't just invent this out of thin air. He had to hunt down and assemble all these scattered, totally confusing puzzle pieces left behind by other brilliant minds, rogue geologists, and some very bewildered naturalists. So let's get into part one, a world fixed in place, the immutability of species. To truly appreciate the sheer magnitude of Darwin's discovery, we gotta rewind. We have to step back into the scientific mindset of the 18th century, way before Darwin even arrived on the scene. For centuries, the absolute prevailing view globally was this concept called fixism. Basically, almost every scientist and thinker considered species to be totally immutable. They believed that every single species had been created completely separately, exactly in its current form, and just couldn't evolve or change over time. A lion was always a lion, right? A fern was always a fern. And honestly, if you put yourself in their shoes for a second, this view actually feels perfectly logical. When we look at the world, a dog only ever gives birth to a dog. An oak tree only makes another oak tree. From our limited human perspective, the world seemed entirely static.
So we're looking at a massive clash of worldviews here. On one side, you've got this deeply entrenched status quo that had dominated for thousands of years, immutable species completely unchanged since the dawn of time. And on the other side, you've got this radical, almost heretical new solution that Darwin would eventually propose. The idea that species aren't fixed at all, but they actually evolve gradually over generations, all branching out from shared common ancestors. So, what on earth caused the shift from point 1 to point 2?
Well, it all started because naturalists began noticing literal glitches in the fixist matrix. Picture this. You're hiking up a massive, towering mountain. You're thousands of feet above sea level, miles and miles away from any ocean. You look down at the rock, and you find fossilized seashells. Wait, what? Why find seashells on mountaintops? From the 18th century onwards, these completely inexplicable fossils became a glaring, unavoidable problem for scientists who fully believed the Earth and its creatures never, ever changed.
And the clues just kept piling up. It was getting weird out there. Naturalists weren't just finding tiny shells anymore. They were suddenly digging up fossils of gigantic, completely unknown animals that had entirely vanished from the face of the Earth. I mean, extinction was a terrifying brand new concept for them. They were even finding the remains of woolly mammoths in regions that are incredibly hot today. Mammoths in Mexico. No way, right? And top of all that, explorers were finding very similar living organisms separated by vast, impassable oceans on completely different continents. These geographical and anatomical anomalies were a massive wake-up call. They proved beyond a shadow of a doubt that the Earth had gone through some drastically different environments throughout its deep history.
But the clues weren't just buried in the dirt. They were hidden right inside the animals themselves. Scientists started finding these astonishing, almost eerie anatomical similarities between wildly different species. Just think about the human hand, the wing of a bat, and a whale's fin for a second. These structures do totally different jobs, grasping, flying, swimming, and yet if you strip away the skin and muscle, they share the exact same bone organization plan. One bone, two bones, little wrist bones, digits. Today, we call these homologous structures, and they act like a giant neon sign pointing straight toward a shared common origin. It was as if nature was taking the exact same blueprint and just reusing it for entirely different jobs.
All right, moving into part 2. The clues pile up. Lamarck, Lyell, and the gift of time.
So, evidence of a dynamic, changing world is definitely mounting. Enter our early detectives. Before Darwin, a French naturalist named Jean-Baptiste Lamarck was actually the very first to propose a coherent scientific theory for how species transform. His main pitch was that organisms change directly under the influence of their environment. Take his super famous giraffe mechanism. He guessed that if an ancestral giraffe constantly stretched its neck to reach higher leaves, its neck would physically get longer during its own lifetime. And then boom, this acquired long neck gets transmitted directly to its offspring. Now look, we know today that this specific mechanism is totally incorrect. Acquired physical traits, like a bodybuilder's big muscles, aren't passed down in your DNA. But we have to give Lamarck massive credit here. He had the groundbreaking, brilliant realization that species are absolutely not immutable. They're actively adapting.
Our next vital puzzle piece comes from a totally different field, geology. Enter Charles Lyell. This guy completely reshaped how we view the literal ground beneath our feet. Lyell argued that the Earth's dramatic landscapes, the Grand Canyons, the soaring mountains, they weren't formed by sudden magical catastrophic events. Instead, they were sculpted very, very slowly by ongoing, everyday processes, stuff we can still observe right now, like rain erosion, river sedimentation, and gradual volcanism. And Lyell's revolutionary work gave us this mind-bending concept, deep time, the realization that the Earth is immensely, almost unfathomably older than humanity ever thought. We aren't talking a few thousand years here. We are talking millions and millions of years. And this was the ultimate gift to Darwin. Why? Because if the Earth is incredibly ancient, it means there is more than enough time for species to gradually transform. Biology finally got the massive, sweeping timeline it desperately needed for slow, practically unnoticeable changes to eventually add up to monumental leaps.
Which brings us to part 3, deep time and competition, Malthus and high-stakes reality.
Okay, so we have a changing Earth, changing species, and an endless expanse of time. But what is the actual engine driving all this change? For that, we turn to thinker number 3, Thomas Malthus. Malthus was an economist who meticulously tracked human populations, and he noticed a pretty terrifying mathematical reality. Human population growth has the potential to expand incredibly rapidly, right? It compounds generation after generation. However, the available resources required to sustain those people, like arable land for food and physical space, well, they remain stubbornly limited in supply. The math is brutal. Populations naturally want to outpace their resources. Because populations are constantly outpacing these resources, Malthus deduced that humanity is locked in a permanent state of competition. Now, Darwin read Malthus's essay, and in a stroke of absolute genius, he applied this human-focused economic idea to the entire living world. He realized that in nature, all organisms, from tiny beetles to massive birch trees, produce vastly more offspring than can possibly survive to adulthood. Therefore, every single day in the wild, there is a fierce, relentless struggle for existence. Competition for food, competition for space, competition for sunlight, for water, literally for life itself. Nature isn't some peaceful, harmonious garden. It is a high-stakes arena, and competition is the universal rule.
Let's move on to part 4, the Beagle's epic voyage, gathering the final clues.
So with all these powerful ideas swirling around, extinction, deep time, the struggle for existence, a young Charles Darwin boards a ship in 1831 to gather the final, definitive pieces of the puzzle. This was the epic, history-making voyage of the HMS Beagle. Darwin spent nearly 5 whole years traversing the globe as a naturalist. He sailed from England, down through the dense jungles of South America, hiked up into the soaring, fossil-rich peaks of the Andes, hopped over to the famous Galapagos Islands, and eventually made his way to Australia and various Pacific archipelagos. And over those 5 years, he didn't just casually look around. He amassed an immense, staggering collection of specimens, fossils, and detailed notes that he would relentlessly study and agonize over for more than 20 years after finally returning home to England in 1836.
It was really during this specific journey that his vision of nature permanently shifted
particularly out in the Galapagos. He noticed that very similar species differ just slightly from one neighboring island to the next. The classic example here is the Galapagos finches. He observed that they had completely different beak shapes, and those beaks were uniquely perfectly adapted to different diets depending on which specific island they lived on. Some had these thick, heavy beaks for cracking hard seeds, while others had slender little beaks for catching insects. This geographic isolation strongly suggested that a single original population had diverged and physically adapted over time to survive in their specific local environments. Now, Darwin didn't fully figure out the exact mechanism right then and there on the islands, but that profound seed, the idea of gradual, environmentally driven transformation, was definitely taking firm root in his mind.
And finally, Part 5. The puzzle comes together, synthesizing the grand mechanism.
So we've traveled the globe, dug up impossible fossils, wrapped our heads around deep time, and recognized the brutal struggle for life. Now we hit the monumental year of 1859, and it's time to put it all together. Just look at the ultimate detective board Darwin had at his disposal. From fossils, he knew Earth's environments changed and species vanished. From Lamarck, he had the bold claim that life actually transforms. From Lyell's geology, he had the immense, deep time required for slow change. From Malthus, he understood the fierce, everyday struggle for existence. And from his own grueling voyage on the Beagle, he witnessed firsthand how geographic isolation creates physical adaptation. So, if you take away one crucial thing from this explainer today, make it this. Darwin's true genius wasn't just being the first guy to whisper the word evolution. As we've seen, other brilliant folks were already knocking loudly on that door. His unmatched genius was taking all those disparate floating clues from paleontology, geology, economics, and biology and synthesizing them. He didn't just say species evolve, he proposed the definitive, undeniable, explanatory mechanism for exactly how it actually happens out there in the real world.
And that world-changing mechanism, that elegant solution to the grand mystery of life, it's natural selection. This is the precise, unguided mechanism by which species evolve gradually over generations, branching out from common ancestors. They're shaped entirely by their ability to survive and reproduce in their specific environments, rather than just being fixed in place since the dawn of time. It was this singular, incredibly powerful idea, beautifully laid out in On the Origin of Species, that fundamentally altered human thought and became the bedrock of all modern biology.
But listen, having a fancy name for the mechanism is really only half the battle. If life is this constant, high-stakes struggle for limited resources stretched across millions of years of deep time, how exactly does natural selection play out in the wild, day by day, to create the absolutely incredible diversity of life we see around us today? Well, that is a fascinating, dynamic process, and we are going to unpack exactly how that biological engine works in Part 2 of this Explainer series. I really hope this deep dive helped illuminate the history for you, and I can't wait to see you in the next one.